Cool. So yeah, Objective-S. I used to actually call this language Objective Smalltalk, but that got people very, very confused. And I still have enough other confusing things, so I'm now calling it Objective-S in homage to Objective-C, although even that is questionable. And that's what I'm going to talk about today. And in a nutshell, it's an architecture-oriented programming language. It's very much Smalltalk inspired. But it generalizes Smalltalk. It's implemented as an embeddable framework. It's VM-less, although of course there's lots of runtime support. It's written in Objective-C, and actually starting to get written in Objective-Smalltalk, Objective-S itself. It's mostly currently an interpreter, very, very simple interpreter, and a native compiler, whatever that is. Well, probably something like a compiler, but it's got stuff missing. So the little overview of the talk, I want to talk a little bit about the inspiration, partly from a top-down perspective, partly from a bottom-up perspective, and talk a little bit why would software architecture be a good fit for the problem I'm trying to solve. And then I'm going to give some demos. First parts is going to be the Objective-S overview, just showing off all the various features. Probably not going to be able to do all of them, and then some larger examples. So why would I want to do this? Well, some guy who seems pretty smart once said, software seems large and complicated for what it does. Let me get it just a little bit here. Yeah, that's better. I'm not talking completely blind. And some examples, and these are, everybody probably has their own examples. My favorite one was one of Alan's, which was Microsoft Office, and he claimed it was 100 million lines of code. I worked for Microsoft for a while. It actually happens to be 400 million lines of code. And that's, I think, and Dan can correct me, it's about factor 10 to 20,000 more than the original Smalltalk implementation of personal computing. And that's a lot, right? If we accept that it's maybe 100 times better, that still leaves somewhere with factor of 100 to 200 of what happened. Personally, I started thinking about this. Things are being too big, of course, a long time ago. But when I was working for Wunderlist, it also really drove that idea home. Wunderlist was a simple to-do app. It didn't really have any sophisticated algorithms or anything, and the iOS and macOS clients were 100,000 lines of code. And this was not because we were stupid. I don't think. There were some pretty good developers there, and we didn't do too many awful things. And it was just way too much code, and it's mostly plumbing. It's just moving things from A to B and B to A, and making sure everything shows up and is in the right places. And this just seems too big. And actually, recently I saw an interview with Eric Schmidt, who before that I didn't have that great an opinion of, but that was because I didn't know any better. He's actually really smart, the former CEO of Google. And actually, as far as I can tell, a really insightful software engineer as well. And he told this story where he wanted to talk to the Gmail team. And so he booked a conference room for, I don't know, I think it was for 6 to 10 people. And they came back to him. It's like, you're going to need a bigger room, because it was more like 100 people. And which just gives you back this idea that, when you don't know the details, what you think, it's a lot smaller than that actually needs to be. And he said in that talk that, this is almost always a problem with architecture. But it doesn't seem to be, something that where we're doing something wrong or obviously wrong. It just seems to afflict us all the time. Oops. Okay. And the one of the reasons, and maybe one of the central reasons that I think this actually happens is that we have architectural mismatch between the systems that we're trying to build these days and the languages we're trying to build them with. And that was kind of where that little slightly controversial statement on my homepage, well, on the Objective-S homepage came from, is the insight that, well, actually the languages, most of the so-called general purpose languages that we have these days aren't really that general purpose. They're domain specific languages for the domain of algorithms. And if you think about it for a while, you think back to what was one of the, the central ancestors. Well, it was ALGOL. What does ALGOL stand for, right? Algorithmic language. And we have moved beyond that a little bit, but not really that much. And it used to be that most of the problems we were solving were algorithmic problems. Initially with scientific computing, ballistic tables, but that has changed a lot. Currently, on my phone, I can't think of a single application where I just give it some numbers, it computes a result and quits. But that is the abstraction mechanism that our languages provide. We call a procedure and it does something and then it returns. And that's just no longer appropriate. And there's lots of talk about this. I'm obviously not the first person to have discovered this. For example, the Guy Steele presentation, when there was some OOPSLA had sort of, our objects dead, and he said, well, it's not about termination anymore. It's about continuing relationships. And objects are some of the best ways of dealing with that, but maybe they're not good enough. And one of the most detailed analyses of this I saw was by a guy called Chaty, Stéphane Chaty, and I hope I'm pronouncing correctly, a French guy. And he has this great paper called Software is Equal to Algorithms plus Data Structures plus Architecture. And he just takes apart GUI programming and how, in this one particular example, how our programming languages are completely mismatched with the goals they're trying to accomplish when it comes to GUI programming. And if you look at, for example, I have this book, User Interface Programming Languages or something, from 1991. You can read it today and we have all the same problems. Nothing has really changed majorly, although there's a little wrinkle with the way we're trying to do with React and stuff, which I'm not going to go into unless there is a question. And so that's one example, and there are many other examples, but I can't give them all. But I think it's a trend. The languages don't match anymore. And so why do I think software architecture might be a solution? Well, again, there's this guy we think is pretty cool, and we love his quip about having invented object-oriented programming, or coined the term. Sorry, not invented it. My bad. And this, I didn't have C++ in mind, and we like to throw that into the face of these, class-based programmers, and we do true objects were so much better. But of course, just a few seconds later, he says much the same applies to Smalltalk. And now I don't know what exactly he meant with that, but to me, my interpretation and my experience has been that we can build these structures. We can write procedural code that builds these interacting structures, but we cannot express them, right? And so, in the words of Andrew Black, the way he put it is that the program is not a direct expression of what we're doing. It's a meta description, right? It's instructions for building something, and the something then becomes invisible unless we have great tooling, which of course why, as enlightened Smalltalk programmers, we know how important the tooling is, and that the language isn't really important. But I would say that maybe we should, in addition to having the good tooling that allows us to make these invisible structures that we built visible again, it might also be a good idea to go back and be if we can't make our languages express more closely these structures that we're building. Boom. So, and of course, there was also this this message on the Squeak mailing list a long time ago, which actually I found very inspiring, where Alan talked about, this Japanese word of ma, that he said was kind of what he had intended. And he's not, when he said it's not about the objects, it's not about, well, it's not about the language, it's not about the objects. It's almost even not about the messaging, although more that than anything else. And this ma was like the interstitials. And for me, this is very, this sounds to me like connectors, right? It's what goes between the components, the interacting patterns, and the communication patterns, right? And again, that's what software architecture talks about, connectors. And another very influential paper was the Why Functional Programming Matters, which I think is also has a great introduction, where he talks about that if we're going to build systems these days, we need many more different kinds of glue, because that way means we can take things apart in many more interesting ways. But then he just introduces 2 and maybe 1.5 functions and lazy evaluation. And to me, again, it seems like, well, we're going to need lots of different kinds of glue, lots of different ways of connecting things. Okay. And so there's again, wonderful paper by Mary Shaw, Procedures are the Assembly Language of Modular Interconnection. And also that's also in the book, Software Architecture, something of a new discipline by them. And that talks about how how architecture description languages are important, and they should be. And we've had some architecture description languages, they haven't taken off. Partly, I think this is because they're incredibly verbose. Describing, a 1-line 2-component filter is about a page in common architecture description language, and I'll go into why that is. And the other reason is they're only descriptive. So, you do description and then you still have to program the damn thing. That's not really helpful, because I mean, if we are able to describe what we're trying to build, then why don't we just use that, and then the programming takes care of itself, or actually it becomes programming. Just a brief intro to software architecture, just so we're all on the same page. Software architecture talks about sort of the coarse grain decomposition of software systems, or composition, their components. They are connected via connectors, and then if once that happens, they're systems. And of course, this is recursive, so a system can be a component again. I'm not sure a system can be a connector in the usual nomenclature, but I think the components and connectors are actually very similar. It's their roles that are different. And components talk to the outside world via ports, and connectors have talk to the outside world via roles. So, in a message, there's a sender. Well, a receiver role. Sender often is not made explicit, but a receiver role and argument roles, and maybe a return. Pipes have, the input and output, and error ports, and so on and so forth. The components do, and the pipes have just the in and out. Styles are classes of systems, which I'm not going to go into. There's been lots of attempts to formalize that. And the last line is kind of how component connection works, right? You have a component, if one component, and that has a port, that port is connected to one role of a connector, and that is connected to, that then has another role, which connects to the port of a second component. That's very complicated, right? Because often when we do it practically, we have at most a component, a connector, and another component. For example, an object, or even a single one, right? An object and a message. The message is the connector, and the object is the component, and it might have more components. Or an assignment statement. Then we have the assignment is the connector, and the left-hand side is one component, and the right-hand side is the other component. And so one of the reasons the architecture description languages tend to be so cumbersome is because they do all of that in full detail. And to be practical, I think you're going to have to elide this most of the time, and that's of course where dynamic binding comes in. So we can be polymorphic, and I'm going to talk about that and show some demos of how that works. And sort of my personal experience is that when you try to actually implement better architectural styles in current programming language, you get some friction, or sometimes a lot of friction. For example, the system I was working on that it originally inspired much of this work was the sports statistics system at the BBC, at News Online. And it started off, as a kind of microservices, but pre-REST style. I'm trying to remember. It was running on like a dozen machines, and was very, very slow, very unreliable, and had close to 100 processes. And we replaced that with a single jar, and that was about 1,000 times faster and never failed. And the main reason, I think, well, maybe not the only reason, but certainly one important reason, is that I decided to style the internal structure like a REST server, because that was what we were going to deliver. And why would I want to translate back and forth all the time? The other system had internal data structures, a database, and different external representations, and it had to translate between them all the time. And that's really complicated and really error prone. When it's all really kind of the same, then there's not that much to do, and it becomes also very easy to see what the system is doing. And there's a book chapter published with Springer about in-process REST at the BBC that gives some more details. But the disadvantage of that system was that now we were doing this in-process REST style. Of course, in Java, you can't actually do that. So we were essentially writing in a meta language that was implemented in Java, and there was a lot of paths and strings that were, most of the meat of the program were actually in these strings, and that's something that actually happens quite a lot. I remember some statistic that 80 or 90% of strings in Java constructors are identifiers or paths. So, I think we've all seen, stringly programming. And similar with sort of a translation of Unix streams into an object representation. I call them polymorphic write streams. Had a paper on them a while back at DLS. And again, there it turns out that if you do call return, this was particularly about serialization, but it applies to other things as well. You get some very nasty performance problems that you cannot remove once you have decided that you are going to serialize your objects using a call return API. And if you change that around and make it a sort of a streaming API, then you can be much faster and much simpler. But of course, it doesn't come natural to do that, because the natural thing is to have some kind of method, some kind of message protocol that says, print string, return this. And when I was at Wunderlist, we also once again I introduced the in-process REST ideas and extended that to storage combinators, and that was really useful. The code in that part of the code base was reduced probably by a factor of 10 and made much more composable and testable, blah, 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 blah. But again, it doesn't match the structure of the program, of the programming language that it wants. So there's just friction. So that's kind of where I'm coming from with Objective-S and why I'm doing this. And so let's see what it is. It's a Smalltalk with that has more syntax and various syntax changes, some that people are probably not going to be happy about. It adds complex object literals, which are a recent addition, but and that was actually not planned, but I kind of just discovered them. And that seemed extremely useful because they let you think about really instantiating, just writing an object down rather than writing a messaging to construct an object. And that actually does have some it seems like a subtle distinction, but it seems to have some interesting consequences. Polymorphic identifiers are sort of were sort of the first step to rectify this mismatch, where you always have to put the interesting things in strings, like paths and URLs and stuff. And so we have a programming language that just knows about URLs, and all the identifiers are URLs. Storage combinators are this in-process REST idea. So you have these REST servers. The protocol is really very dictionary-like, just the REST verbs as a protocol, and then they become pluggable. And they're the evaluation base for the polymorphic identifiers. So you can change what your identifiers mean. And of course, it does also have the polymorphic write streams, and it turns out that these interact very nicely with storage combinators. So you can just plug things together and get useful functionality. I'll show an example. And then there's the arrow. The arrow is connect something, please. And that's kind of the first. I mean, the other things are kind of implemented, but they don't really show any new syntax or anything for supporting our software architecture. The arrow is is a really very direct manifestation of I'm connecting things here, and it's polymorphic as well. So it can often connect things without being too detail oriented, but you can give it more detail, and then it'll disambiguate if it needs to. And of course, I'll show all these. This is one graphic that to show how storage combinators and the polymorphic write streams interact. This is an asynchronous JSON store. The idea is that on the top level store, that the caching store that you see in the top left corner is what the application is hooked up to. And again, the API is like a REST server. So you have get, put, delete, well, some other details, but those are the important ones. And a caching store, like the name says, has a cache. So it has a memory cache, which you see on the bottom left, and it has a source where the true data is. And when on reads, it just looks in the memory store. If it finds the stuff there, it uses that, and if it doesn't, then it goes to its source, which is the JSON converter you see on the right, and the JSON converter is actually connected to the disk. So, yoo-hoo. On write, it does something slightly more sophisticated. Maybe I should have shown the non-sophisticated version, but writes you want to be asynchronous. Because otherwise you're limited by disk speed, and then why do you have the cache in the first place? And so instead of actually writing, the caching store is connected to what is called a logger, and this is another store that just passes its requests through to its source. Although in this case it doesn't actually have a source, and it logs all the operations that it was supposed to do, just the URL and the operation, whether it's a get, a put, or a delete, to its logs, to its log. And in this case, that is connected to a queue, and that is connected to a copier. And the copier is another stream. The queue is a stream that functions as a queue, and it does some uniquing and stuff. And the copier is a queue that is connected to stores, and it just, when it receives an operation, it just performs that operation relative to its stores. So if it says, in this case, it just receives the puts, and then what it does, it puts whatever it gets from the memory to the JSON. And so you now have a decoupled write built out of existing components, just a couple of polymorphic write streams, the logger and the queue and the copy, well, the queue and the copier, and a bunch of stores that are actually also useful in other contexts. This is not specific. And we used this in Wunderlist, for example. And of course, for example, then when you're testing, since all of these stores have the exact same interface. So for example, if you're testing, you don't use that. You use you replace that with with a pure in-memory store, and it works the exact same just for the tests. And then when you want the production implementation, you put in this, and it'll work the same way, except for slightly different performance characteristics. All right, let's see some code. The first I'm going to show some basics of Objective-S, the basic syntax, and curly braces instead of square brackets, and message chaining, and a couple of other details. So let me get that. I should be doing, where is that? Yep, here. Let's see. So 3 plus 4, is it a small talk? That's yes, it's a small talk. We're done. Okay. End of presentation. And of course, well, I could have shown the here, edit, print it, and and I was just hitting Command P instead. Hello world, comma world. Let's see what that does. Yeah, hello world. And this I'm going to evaluate quietly, and then of course, so it also does string interpolation. So first big departure, I think. Well, the left arrow. So we have Unicode now, so we don't need to use underscores or colon equals, although colon equals also still works. It does have string interpolation. So if I evaluate this, it'll do the string. It also does interpolation in polymorphic identifiers using the same syntax. Basic collection, this is completely mostly expected, except that I don't, since it's built on Objective-C, it doesn't necessarily return the the printed file in format, which sometimes does something different. And again, please, tomatoes this way, right? Blocks have curly braces. But they still work as you would expect. One, I think, useful innovation. And it works with intervals, of course. And I think one useful innovation in recent times is that sometimes it's not worth it to introduce a new name, and you can just use strings, $0, and that'll work the same. Yoo-hoo. Since I wrote it up, it obviously supports higher order messaging, which I think is just in many ways the way you should express this sort of thing. So collect, star times 5. And of course, one of the neat things about higher order messaging is that it works, it can work in any position. So for example, I have a single receiver here, and I'm going to collect over the an array enumerated in the argument position, and that also works. So I get hello world and hello UK Smalltalk user group. This is a dictionary. This is, so another departure. This is a dictionary. the hash curly brace, and so we got a dictionary. And yeah, since the square bracket is now free, we can actually do indexing. And yes, more tomatoes my way. The idea here is actually not to leave it at that, but to support, particularly when you're talking about polymorphic identifiers, to go and support something more akin to XPath-like syntax, not to leave it at just that, and then it becomes more useful. Oh, the cascades went away. Let me put the cascades back in. Let's see what I did. 1, 2, 4, right? And that's that. And if I say, well, if I want to add 5 to all of them, right, I might do this, right? Or multiply by 5, right? That was that. But actually, of course, that doesn't work because it binds differently. Now I have to do this to get it to evaluate the way I want to, which is, I don't know, I don't think that's nice. And of course, Smalltalk 80 has this lovely cascade syntax, but that only works if I send to the original receiver. So I have the same thing for piping, and I use the pipe symbol, and that will do what I want to do. And I find that very handy, particularly because it's also in a REPL, and just having tried it in various types of code, it makes, particularly when you have, cascade, not cascades, but sequences of keyword messages, it can make them much more readable rather than having all the brackets in. Yep, we have class syntax. There's class. I could give it a superclass. Oops. Yep. I'm based on Objective-C and Foundation. And different types of these classes can have different implied superclasses. This one is NSObject. So I define a class greeter and with a hello message, and it just does what we did before. And if I evaluate that, I get the greeter class. And I can now instantiate it, send it a message, and it does something completely surprising. And again, the idea is to be interoperable. So we do need to be able to have files. We also want image type capabilities, but we don't want to be tied to them. We can also do extensions. So instead of saying class, I can say extension NS number. That the NS number is the Objective-C number of class. Not too happy about it, but it's the one we have. And I just define a factorial method that does the factorial using the reduce operator. Oh, wait a second. Okay, so I should probably try it out. So 4 factorial. Yeah, that's expected. 20 factorial. Oh, oops. I mean, it's probably sort of correct-ish, right? It's roughly the same thing, but it's it's not nice. So, can we do something about that? Well, yes, we can, of course. Otherwise, I wouldn't have brought up this example. So I'm going to load a framework. Load some binary code. That's the objective arithmetic is a really thin shim on top of GMP, the GNU Math Multi-Precision Library. And yep, okay, we could load this. And now I need to make sure that if I'm giving a literal, it's going to use the big integer class and not the NS number class. And then if I evaluate 100 factorial, yoo-hoo, we get proper answer, yay. Of course, this is nowhere near as good as a true numeric tower. I've not really had time to look into that in detail because my focus has been on the architecture stuff. But yeah, we can get there. And of course, we can also do simple UI. So I'm going to see if hopefully I didn't break it. I want to open a browser, and I'm going to give it the browser can take as an argument any kind of one of these storage combinators. In this case, it's the file scheme. So my file system, and if I do that, I get a disk browser, and I'm not sure anybody can see this. Users Marcel. Programming. I'm going to use this Zoom thing. I think. Yep, there we go. Kids, objective, small talk, so on and so forth. Oops. Yeah, on Zoom. Yep. And that was my first demo of basics. Any questions, comments so far? Or tomatoes? I guess we don't have a tomato or rotten egg feedback mechanism. Okay, so what did I want to do next? Oh yes, right. So then I mean, so that was sort of basic small talkish things with minor variations. Of course, not as good as real small talk, but enough to get me going. And now we get to the more interesting stuff, and I'm going to be in a shell for this. So polymorphic identifiers, all identifiers are URIs, and vice versa. So obvious things, file system access becomes very simple. We can talk to the web very easily. All this is resolved dynamically and can be parameterized. And we can also talk about the identifiers themselves, which is kind of a object-oriented / metaprogramming equivalent of a pointer is a ref colon of something. And I will show this. I will try to show this. There we go. So here we are. Should I make it bigger? Yeah, I should probably make it bigger. So just to see, I mean, there's the Smalltalk scripting shell, I call it, and I just run that, and then the basic things work. But what that actually is something that's in the var scheme. So if I say var a is equal to 2, that's the same thing. And that's doing the last thing first. If I say ref, the ref to ref var a, and the ref is a binding, and I can then say a value. Oops, what? Oh, and that's that. And yeah, Objective C conventions. Sorry. And if I now say a, it's 3. So that's very useful in terms of, I mean, let's see, in many small talk, I think certainly Syncom small talk has what they call value holders, sort of kind of separate mechanism, and this kind of replaces that sort of mechanism, right? If you can just give some object a binding to whatever your variable you have, and then it can manipulate that in a generic fashion. Objective-C also had a mechanism like that, which was completely string based. And again, you have that problem that you're implementing this separate language on top of your current language, and then half of your programming is written in one language and the other half is written in this other language, which is embedded as strings in your first language. And it all gets very, very messy. This has the same functionality, except it's all integrated. Or, well, the other option, of course, is to either go sort of the tickle route and then say, well, everything is a string, and then you just have one thing, but it's maybe not the right thing, or sort of the halfway house of Python and JavaScript and Ruby, where everything is a dictionary. I call these the hash languages first, because everything's based on a hash, and the second reason is because it's very easy to make a hash of things. All right. So that was basic variables. We can also we have other variables. For example, we have, of course, the file system. So file : dot is the current directory. Oh, it's not doing the multiple rows. Let's see. Not big enough. Nope. Well, and that's the current directory. Let's see. File dot add 3. It does file completion. That's that file. I can look at the temp directory. Whoops. Well, I can also autocomplete incorrectly. And actually, let me go into make dear. It should be empty now, right? And then if I say file hello dot text is UK stug, I can just use plain old assignment statements, and then file dot hello dot text of course contains this, and the file is there. And if I go here, it's also here, right? So we're interacting the same way with anything that's a variable that we can consider a variable, including, of course, HTTP. So Amazon, it's my local, and I get it, the web page. Of course, I don't have a browser built in, obviously, but if I want to see how big that is, I can just send that a message. Well, oh, if I can remember the correct message for getting the length of a data, then the basic Amazon web page is 580K. So, and of course, if I want to download that I can, of course, do that. Amazon homepage is equal to HTTP. We'll take them, and then page. There we go. We have a bunch of other schemes built in. These are listed in the scheme. For example, we have the environment scheme. Oops. Well, that's the scheme. That's not what I wanted. Of course, I wanted this. That lists me the environment variables that there are, and of course, it uses the same kind of formatting that we get with the files. And if I want to look at something, for example, and home, that's my home directory, and the user, that's it's case sensitive, so that's me. There is Mac OS also has the default scheme. Default scheme that has various the defaults database. For example, that's my key repeat rate, and you can bring all sorts of manner of hierarchical or non-hierarchical methods, stores into that. For example, I don't know, processes, file tabs, or any kind of, and particularly also, of course, the important part is your own data. So, I did show ref, I showed HTTP. Let me go back and see if I missed something important. Yeah. Oh, parameterization. So, for example, I can do file : and home, and then that's my home directory. All right. So the interpolation also works for polymorphic identifiers the same way it does for strings. Okay, back to the demo, that is to the slides. Did I close the slides? I closed the slides. Oops. Well, now I get to see the do it. Here it is. that's the presentation. There we go. And sadly, I haven't implemented go to page, so apologies. By the way, the slides are these are done using Apple's Scene Kit, and the inspiration came from a dub presentation by the Scene Kit team, who did their presentation as an app, which I thought was very cool. You know, an app written with Scene Kit that did the slides. And so what I did is I took that app, decapitated it, so it's no longer an app, but a framework. And since Objective-S can interact with Objective-C frameworks on an equal footing, I could just use those. And using the literal syntax, I just define my slides. There we go. Chunk. Next. Right, the storage combinators. And now it gets more complicated. And so we saw that we can interact with these schemes. The schemes are sort of the interface for some kind of combination of storage combinator. And when they're integrated into the language proper, then they're called schemes, because just that's how what we call these things with URIs. Okay, so we can and since it's in process rest, it seems obvious that we can also do web servers, and yes, we can. And I need to go see my, and this time I'm not going to close it, but I'm going to go put it away. And we need to look at the web server. That's the one. So this is the script that is the web server. Just the shebang. It needs to load the HTTPD framework, because it's not built in. And then it defines a store. It's syntactically, it's still called a scheme here. And this is this is like a class definition, except that there's a bunch more like these, and what they are is essentially class templates. So if you have a class a definition of this type, it means the class should be of a specific subclass unless otherwise specified, and there may be some substitutions. And that came from, I actually saw this class template kind of thing as a proposal for the C++ language, and it seemed like a really good fit, because the thing I discovered over time, and that I also mentioned before, is that with object-oriented programming, usually you can implement most of these architectural constructs really well as just classes that then turn into objects. The problem is that there usually is some boilerplate involved. And so it turns out that in order to have nice language support, most of this language support boils down to having nice, not all of it, but a lot of it boils down to just being able to define classes with less of this boilerplate. And then having that, again, look like built-in language constructs. So I'm defining a sitemap, and it responds to, well, it defines the path hello, and this is a get, and the get is just return hello world. And then the sitemap is served on port 8090. So let's run that. So, and oh yeah, it says run interactive loop. So because otherwise it would just quit immediately. So this is just to run it until I'm done with it. And then I can go to localhost port 8090, and yay, it says hello world, and it also wanted to get the fav icon, but we don't know about that, so there's an error. And if I quit this, then it says the server is not there. Yeah, I'm going to come back to that, but this is the definition here is something which I call a property path, which is an extension of the property construct. You now see in a bunch of languages like Objective-C, and Python has them too. I think C# has them too. They are actually useful. And the idea being that one thing I think REST and the World Wide Web has shown is that what we did, defining that state is internal, and methods, procedural interfaces are for external, and those are the only ones that can be dynamic. This doesn't need to be true, right? And whenever you have a web server, particularly if it has a CGI bin or some other dynamic construct behind it, you can have a state-oriented API and back that with with the procedural implementation, which is the wrong way around from the object-oriented perspective, but it actually works really well. Particularly because it has the REST properties of composability, because there's so few verbs, right? We never really got the composability, I think, quite as good as we thought we would. Corba is an example. It's just because you can't have generic intermediaries. With REST, and with it, that's what was one of the insights for storage combinators, and in process REST you can actually just map this nice composability, and you don't actually have to do inter-process communication to get it. You can do it in your process. So that was HTTP. And then we can do more complex things. We can serve a directory, if I can remember the no, that wasn't the one. Damn. Let me think what I needed. It's the I think it's the home file server. Yeah. Okay. So just have to look what port that serves. Port 8088. And this is this looks. Let me do that again. So this is very, very similar. It has a shebang, it loads the framework, and it's a bit more verbose because it's older, and I haven't really updated it. So it gets this, an HTTP server sets the port, and this is where it gets the directory from. So it says, well, this is the string that defines my home directory, and add sites to that, and be in the file scheme, and don't return that, but to return the reference to that, right? Because I don't want to actually assign the contents of that directory. I want to have the directory itself. And then I cache that because I don't want to hit the disk every time, and then I run that. If I actually run that, then on port 8088, I should get my the file server. Yeah, there we go. And there's a file in there, and there's another directory, and there's a little file in there, and that's the same as in the sites directory of my home directory. There we go. It's the same thing. Okay. And you might also think that since we have a hierarchical directory-oriented structure, it might be possible to export this to the file system, right? Like in Plan 9, like everything is a file system. And of course, we have Fuse, file system and user space, and we can actually do that. And for example, if I wanted to mount my environment, I do I load the Fuse mapper, I add a little, I have a little extension mapper, because with TXT extensions, the Finder will be happier showing me the files. If it doesn't have an extension, it complains. So I add TXT to an extension TXT to all the names. And then the base scheme that I'm exporting is the environment scheme. And then I have to mount that and return the file system, and then run my interactive loop again, so I can do something, interact with it, and then if I terminate that, it'll unmount. And if I do that, if I run that and get my basic, all right, here is my, so let me zoom in again. That was like this. And if I start, okay, I now have something mounted here, and it happens to be my environment. So if I use, let's see, where is home? Well, there's the path, and that's, that's obviously path. Well, okay, zoom is not doing what I would like it to do. Home, users, Marcel, that's my home directory, and so on and forth. And then if I unzoom and find the find my shell, which is here, and if I hit Control D, it's gone again. It's unmounted. And I can actually, this was a specific example, but I can generalize this, and this here is mostly the same, except I can pass the scheme as a parameter, and then any scheme that I've developed and that works in my programming language, I can, as we saw before, I can export that to HTTP, but I can also export it to a file system and make the Plan 9 people happy. And let's see if I mount scheme, and that has the same effect as before. That's once again my environment. But I can also mount what I had before, which was the defaults, and now that is mounted in my file system. Zoom, applical, what was the languages, and so on and so forth. Again, and that's a really interesting discovery, is that once with these abstractions, things become just very composable all of a sudden, in ways that weren't obvious. I mean, they certainly were. I mean, I'd like to claim that I knew this all along, and but it was actually, a lot of this was surprising, just how composable and how easy it becomes to plug things together, which wasn't before. And I've been thinking about why that it actually is, and I have ideas. I think this idea of this not idea, but this structure of with the rest, just having a few verbs that are always the same, makes things very syntactically compatible. Just like, I mean, the most compatible thing that we have is Unix pipes and filters, right? Because any filter element you can plug into anything else. It's just very, for many applications, it's very difficult to make that do something useful. If it works, it's great, but oftentimes it's just not what you want. With the plugging these in-process REST servers together, it becomes quite useful. And of course, there's always the escape, because I mean, we're not saying this should replace what we have. No, it should just do the naming and namespaces and storage stuff. And then when we do computation, we still have, well, small talk-ish, right? Again, I'm sorry. All right. Okay, fuse server, blah, blah, blah. Let's see, polymorphic, right? Oh, oops. wrong slide. But I do want to show polymorphic right streams just for a second. Have that here. Yeah, to upper. Define a filter, and this is like the scheme. This is a class definition, and there's some more gobbledygook here. The pipe bracket means this is a filter method, and that means it doesn't actually return anything. The caret, which we didn't need before, means send result. And actually, in this case, it doesn't send the result back to the sender. It sends the result to the next filter in this pipeline, right? And the processing is just, I'm getting an object. Well, I want to stringify it because it's probably just a bag of bytes. And then I, say, please give me uppercase string, and then I pass that on. And then the pipe definition is, well, I want to go from standard in. I connect that to this filter, and I pass that to the raw standard out, because the standard out is the normal standard out of this shell is cooked, and we don't want that in this case. And I need to actually run the whole thing, which is also an interesting difference in our call return languages basically have, is it called apply eval or eval apply, from basically from the Lisp days. This is slightly different. This is connect and run. We connect, or define connect and run, right? We define our objects, we connect them up, and then we say go. And these are different stages. And again, if I run this, it does the expected thing. Hello world, blah, blah, blah. So those are polymorphic right streams in sort of in a nutshell. And again, we want some syntactics, because I can define this as a class, but it's about a page, right? And because it's a page, you're not going to do that if you could get away with writing a method. And so in order to make writing filters as common as methods are now, we have to make it as convenient. And right now it isn't. So that's the idea, is like make these different architectural styles as convenient as writing methods is now. So we can use these alternative, or we have less disincentive for using these sometimes much more appropriate architectural styles. Let's see, what was it called? Yeah, dismantle procedure privilege. Yay. Oh, right. That was that. And okay, so now for some bigger examples. I already showed the browser. And I mean, the basic idea also is, once again, once you have this well-defined REST structure, your browsers all become the same. So you can use the same browser for just about anything. And that, of course, makes GUI programming a lot easier. I mean, the Smalltalk browsers are already pretty good, but there is still quite a bit of boilerplate to do the connecting. And the idea is to not have that between the GUI and the model, but to keep this adaptation within the model. And then we can do all the other stuff too. And the GUI comes in as a freebie. One of the things I wanted to see whether this would be useful for sort of like a to-do MVC tasks backend, and since having worked on a to-do app, I wanted to show that. So a very simple definition of a backend for something that returns tasks and can interact with them. And I think I'm going to have to scale this down this time just a little bit. Otherwise, it's not going to fit at all. Okay. So this is a very, very simple but essentially complete backend for backend for something that deals with tasks. We define the model, which is again a very simple model. It's a task class. It has an ID, has a flag, whether it's done. This is syntax for types. We'll see how that works. It's a placeholder. I needed one, and but I'm not sure if that's the final thing. And it needs a title, and then we can have a description. And then using our syntax, we can define some literal tasks. It's a list of 2. It's not a lot. And then we have a scheme. So it's one of these stores. And in this case, it's a mapping store because it'll actually talk to lower level stores that can do things like serialization and stuff like that. And that has the list and the dictionary, and we initialize this. This is not very good code. It's just setting up the dictionary from the list that we have, so we can index by ID. And these are the actual. This is the definition of the API. So it's going to have a tasks endpoint, and that's going to just return the list. And you can get a single task by its ID, which will look this up in the task dict. And this colon is short for instance variables. I couldn't use self for weird reasons. Maybe I need to, haven't gotten around to fixing it. And this can also handle put. And so if you send it a JSON, which we'll go into in a little bit, it will put that in the dictionary, and then it will say to persist. And persist just says, well, I have a source, and I want to put my task list at the source, at the tasks variable of my source store. And then we initialize, create one of these and set it up with our initial task list. And then we have a converter, a JSON converter, and this converts, this is in direction up. That means from coming, well, we'll install this between us and the web server, right? So that when the scheme we had is just returning objects, this will return from objects to JSON on a read, and from JSON to objects on a write. And it has to know about the task because JSON doesn't specify. And then we put this together. And we have this initial JSON converter, and we hook that up to the to-do store. And then we have a second converter that's below us, and that's between us and the disk. And that'll convert, when we save, that'll convert to JSON. And we put that in temp tasks. And then you've already seen this. We do the server dance. Its scheme is this disconnected mess right here. We start that, and we put out some information, and then we are good to go. And let's see what port 882. We run it. Okay. Oh, it didn't. I still had something on 882, so it's going to be on 883. And if I go to my browser. 883, and just to have the root, it's going to say not found because there's nothing there. It didn't define anything for that. But if I say tasks, it's going to return me these in JSON. And of course, it'd be not much nicer if it did something in HTML, but this is supposed to be just the backend. And so if I say task/1, it'll give me that task. And if I say /2, always think it's 0 and 1. Yeah, it's 0 based. And actually, I don't remember how to. I don't remember the curl syntax off the top of my head, so I'm not going to demo putting something in. But it would. It has worked in the past, and I probably broke it now. But I'm not going to try and demo it. So that was tasks. What? Oh, wait, okay. The browsers we did, the site builder. Okay, this is an actual application that I use, for example, to maintain websites, the site builder. And that is the Objective-S homepage and a bunch of browsers. And there is a class browser here, and that has some code, and we can modify the code. And this is the resource browser. And so, for example, Objective, I can edit that in line. And it's the idea was kind of to have a to resolve the conflict between sort of static site generators and GUI apps for creating sites. And this is kind of does both, because this is all just files, and it renders using the methods that you give it, but you can also interact with it. And let's see. For some reason, sadly, modifying the code currently does not work interactively. I broke that, but in theory, I should also be able to just site page. And so, for example, if I modify the page copy right here, it should do something here, but it currently doesn't. So, whoops. And so now we can. And we can make people happy, right? And so, problem solved. And the way this actually works is that the site is defined by what is called an ST bundle, which is the slight variation of a Apple NS bundle, which is just a directory that is treated as a file, and inside that directory there are specified subdirectories, and you can put more stuff in, and you know, you have some classes and you have some resources. And for example, I mean, that's just text, but we also have the PNG, and we can also drop stuff in here. So again, images are great. File system type access is also great. Why not have both? Oh, there. The site builder. Oh, okay, and we can also build GUIs using very similar techniques. So we have the view builder. Let's see. There we have. Okay. Sort of a hello world. We need the app kit player. So this is sort of the simplest kind of GUI definition. We have a field, and we want that to be an NS text field, which is the Cocoa standard field. We could initialize it here. Initial value, and then what we do is we connect the field, and this is the right arrow again. Oh, we think it's really small. Zoom, zoom, right? Oh.
You can see it all right. It's fine.
Oh, okay. Well, okay, cool. And so I connect that to standard out, and standard out is piped into this field here. And so if I start typing here, you know, hello, it'll stuff. And so that's the connection. I can also connect this to something else, like a ref text field out. Then to, and since it's that's a variable, it'll replace the whole thing each time. So this is not going to be appended, which is why I don't know why I kept typing stuff. I'm just confused. What? Oh, well, that's not going to work. File, text field out. Okay. lots of stuff at once because that goes into the file. And I think I hope it's becoming clear that the power of this right arrow with combined with combining software architectural ideas of connectors with the polymorphism we have from dynamically typed programming languages like Smalltalk, because it's in this case it's just connecting two components, but it's obvious what it has to connect because each one of them has the default, and there's some matching involved. So it's matching the default input output port and the default output port that is compatible, and so it just works. And if I just go back to standard out, that's different, but that also works. So more typing. And let's see, more on this connection front. Oh, I've done over an hour. Wow, I didn't think I had that much. We can also do sort of this is, let's see, make this smaller. So as you can hopefully see, the output here is is alternating. And what I did is I connected a label. That's my the UI element here, and I created a pipe, a filter first. Let's see. Let's look at this in detail. So that says just hello, and whatever the argument object is the argument of the filter, the implied argument. So it just says hello, whatever you send in, and that's a filter. And then I create the fixed value source, which is the thing that does the blinking, and it has two values, Marcel and Doobie, and it's going to alternately send these on its output port, every 2 seconds, the other one. And then I just connect them up, and then I start the whole thing, and then I have to return this so the view builder knows what it's supposed to actually put in the field. This is very primitive, but it works remarkably well already. And of course, my colleagues at HBI are doing much more sophisticated stuff with live programming. And now that I'm sort of at this state, I can start talking to them and make this actually cool. Although I think it's actually pretty useful already. We have a temperature converter, if anybody wants to see that. It's a bit bigger because there's a model involved. So this is just the model. This is defining the two fields, instantiating the model here. And then here is the setting the connections up. And then this is laying the stuff out, and yeah, it does work as expected in both directions. Yoo-hoo. We can also do sort of more visually interesting stuff. If we start, do we have the? Yes, we do. There we go. This is just laying out, some info panels essentially. What might be somewhat interesting, it's not really visible right now because of this is an M1, but that's actually a UIKit application. So we can interactively, do something. Let's see. Change this around. It does something, and of course, there's resources as well. So here are the images, and the definition is this is the definition of the. I mean, there's a model, there's a planet class. This sets up the model. There's the two planets, Mars and Earth, with the diameters, the image, and some of the additional information. And then this lays them out. It puts them in an H stack. The two horizontal stack. Each one of those is a frame of 800 by 600 spacing. And then it defines these individual subcomponents by collecting over the planets and then instantiating the vertical stack of the elements that are defined. And this does the layout of the elements. And another thing that might be interesting, let's see if I don't actually have that here. So here's another, of course, here's another scheme, color black. For that's in UI, we have that. We have font style headline. That's a special scheme that defines these kinds of things. And again, the idea is to kind of separate things that are just sort of naming elements that we can access via some kind of path, accessing attributes, and we want to access these by actual path rather than sending messages. And we reserve messages for actual doing interesting computation, and we don't want to mix the two. And of course, what is this HStack thing, and why do we have that? And the reason is that we are able to define some shortcuts, object templates that can be used when we're naming these literals. And let me just look for that. Planet, that's here. Oops. No, it's not here. Where is it? Did I put that? Nope. Okay, here we are. So this is an object template, and it says VStack is a stack with these fields already initialized. So that these are default fields. And so if I make it stack, VStack, it's just a stack with some fields already filled in. And again, this was also just sort of a spur of the moment, and it's proven surprisingly useful because it turns out that a lot of the time, particularly when you're dealing with UIs, and this actually came out also out of the 1991 book by Brad Myers, that UI tends to actually be, I'm just configuring objects, and being able to actually do that with a little bit of syntactic help makes it a lot nicer to do this. And another detail that's maybe interesting is that I'm actually able to use within my language, which is not really connected to the Objective-C part that much, and it's not, it's running on AppKit, not UIKit. I can actually use UIKit enums. Now, if you remember C, enums are pure compile time constructs. I can't get these via the runtime. And so you can see the C colon here, and that's actually using libclang. I was able to extract those enums and the values, put those in a dictionary, basically a plist, kind of like a JSON file, and then just add those as one of those stores. And I just add a scheme colon C that's initialized with all those values, and woohoo, I have those enums from C integrated at the language level in my language in a different under a incompatible operating system. And I thought that was actually also surprising, that worked this well, because usually that's a big pain, because again, the enums are not runtime constructs. So if you're just bridging this at runtime, you're not going to find them. And so yeah, that's the view builders. And another thing that I've noticed is that with the object literal syntax, that in theory has a one-to-one correspondence to inspectors. And that's something I definitely want to explore, so that you can have more, more GUI integration for object building but despite the fact that they're built by code. So you sort of have a one-to-one correspondence between those two. I think I'm probably mostly done. I mean, there's more stuff, but I'm probably, yeah, actually I've reached the end of the presentation, and I'm also talked out, and I probably have already bored you all to tears. And so I'm going to put all of us out of our misery and open it up to questions. And stop sharing the screen probably, so I can see people. Oh, everybody's gone to sleep.
I had a question about the Fuse store.
The view
Sorry,
store?
No, Fuse.
Yeah, oh, the Fuse store. Yes, yes.
Yeah. So can you get the file system events to propagate changes back up to the Objective S level?
Oh yeah, yeah. Actually, that is a demo I wanted to do.
That would be really cool.
Yeah. So I mean, I haven't. So I actually there's a whole separate section which is sort of constraints, and I can do constraints using what I call a permanent assignment operator. And I guess I need to share a screen again. There we go. And I can also share and this was also one of these really surprising insights. And actually, my colleague Tobias Pape pointed out to me that, well, wait a second, what you're talking about, you should be able to do Dropbox in a single line of code. And going, yeah, actually I should. I'm not quite there yet, but getting there. So I have scripts. This is the line of code. It just says target scheme should always be equal to the source scheme. So contents, these should be the same. So it's one way. And here I'm just defining those as the arguments. And I need to turn those in, the arguments are references, and I need to turn them into schemes, into stores. And then I need to run the whole thing so it's actually active. And if I run this, and I'm first, and I have these two directories, private temp sync source, private temp sync target. So actually I did prepare this. And I don't know if you can see, there's a sync source, there's the sync target, they're both empty. And now if I, oops, okay. So I'm now going to put something in the sync source. What's this? Hello world. Oh, that's a good example. Sync source. And yep, and it got here and it got propagated here. So yeah.
So could you also say constrain it to an Objective-S collection object so that like the Finder would show what's in the collection?
Yeah, I mean, certainly the Finder showing what's in the collection, that's kind of what I did with the Fuse stuff, right? The other way around is all, I mean, yeah, I'm trying to remember whether I've actually implemented all the details, but that's sort of how then if I do drop stuff in a browser, in a browser, or make some changes to the file system, then the browser will update. And the way that works, and actually I described that in the paper, but in the storage combinators paper, so I have to is the log that I showed. Do you remember the async writer construction that I did with the storage combinators? Mm-hmm. That had a logger, and the logger basically is what enables this. And it turns out this async writer is kind of a one-way constraint already, right? It says constrain what's in the on the disk to be whatever is in the whatever is in the cache. And of course, you can run that the other way around as well. And to get the file system, I had to then make a polymorphic write stream that wraps Apple's file system notification mechanism. And once I had that, then it integrated with everything else. And so everything else then now works.
Very cool.
Yeah. Where is, oh, I need to stop sharing again. There. Oh, there's people. Oh, yay. This is actually also something I've also written about before, and to me it solves a lot of the GUI and back-end, front-end plumbing problems. Once I was finished with the Wunderlist thing, I did a couple of talks about that, and essentially most of Wunderlist was really a bunch of one-way data flow constraints, right, or two-way. So you initialize it from the store. That's okay. That's an assignment. You initialize your memory model from the store. The GUI is connected to your memory model via a two-way constraint, right? It's just supposed to have the same thing in there. So if the model changes, the GUI should update. And if you change something in the GUI, the model should update. The backend and the model are just, again, it's just a two-way constraint. If I make a change, if I make changes to my model, that should propagate to the backend. And if the backend changes, that should propagate to me. And then my disk, my local persistence is a one-way constraint, is because I already initialized it. And whenever I make changes to my model, it should just reflect that on in my persistence. And then that's most of the app. And when I presented that paper, that was a couple of years ago, I only had constraints that could deal with sort of single variables. And the two things that were needed to make this really happen was I needed to be able to group those constraints, which I now can because I can constrain entire stores to each other. And the other thing is I need to be able to build the constraints out of different pieces, right? Because the GUI GUI model constraint is different. I mean, it has the same types of elements. Notification and data update is always the same thing, but it's implemented differently because the GUI updating from and to the model is different from the backend updating to and from the model, and it's different from the disk store updating to and from the model. So and you need. So again, there's polymorphism in play, but on the architectural level, and we should be able to say, okay, all these are constraints, but there's slightly different kinds of constraints, and I should just be able to plug them together and say, okay, these are the constraints that I have, and so I need grouping and polymorphism in my constraints, and then I can build the whole thing in a couple of lines of code, and I can build Dropbox in a line of code as well. Still not there yet because I don't have the remote messaging yet there, the notification of changes, but that's not actually hard. I just haven't gotten around to it.
Very cool.
Oh, okay. Somebody mentioned the GPIO. Yes. Yeah, that's, I can't show the recipe. So this Objective-S also runs on Linux using GNU-step. GNU-step is great. And that also means it runs on a Raspberry Pi. And of course, Hello World on a Raspberry Pi is you need to blink some LEDs. And with Objective-S, and I once again I looked at sort of the sample code, and the procedural way of expressing this just doesn't feel right. And I also want to. There's this, like a lot of people my age and maybe a little older or not much younger, we grew up with these wonderful home computers. You turned them on and it was just basic, and you could type in something and it would do something, right? And for some reason, we don't have that anymore. It's really bizarre, even though we've advanced so much in so many ways. And I really loved the intro to the what do you call it? The Salon de Refuse at this workshop at programming. Convivial, at that time it was called convivial computing, and they said, you know, they promised us bicycles for the mind, and what we got was aircraft carriers instead. I want my bicycle. And so the GPIO example, let me just bring it back up. Where is it? Raspi, and I will share screen again. Ka-chunk. Ooh, can't see that thing. Okay, so there's a slight variation of the Smalltalk scripting shell, which is called the Raspi shell, which also has some predefined, including that it treats the GPIO pins as a store, as a scheme handler, which I think makes sense because, you know, GPIO:17 is 0. That makes sense to write it. And so if I want to blink at one of these, we had the blinker. Last time we saw it, it was blinking between two strings, but it can also, by default, it blinks between 1 and 0. And once we have that, we also saw that we can connect things to a variable. In the last time, it was a file, or it can. I mean, we can treat a stream. It was wrong way around. We can treat a variable as the stream of its values over time. So, you know, we can hook a variable up as a source or as a sink of a stream. And so we hook that up to GPIO pin 17, and then we run it. And then when you hit Control-C to terminate, it turns it off again, just, you know, because being nice is good. Yeah, and I can see that, you know, I haven't done much with it. There's one guy in Austria who's been pushing me a little bit on this because he's using it for various Raspi things. So, and he's doing some really cool stuff. I wants to do something with ultrasound ranging, and yeah, it's really cool. And I think this hooking things up, you know, also, I mean, particularly with circuits, of course, it makes a lot of sense. And so, you know, you can see yourself, you know, hooking up an input pin, and then doing some inversion, some processing, and then hooking up to the output pin, and having it all be expressed as I'm hooking up these elements and filters and stuff. And then, of course, you also get an easy, well, straightforward mapping to some kind of GUI representation of that, just like you can actually with the stores. That also makes sense to hook up.
So architecturally, would you hook up, say, a checkbox the same way you hook up the GPIO?
Yeah.
Sorry, I couldn't hear you. There was interference. I'm going to mute myself again, and maybe I can hear you now. That was Mike, right?
Yeah. So I was just saying, architecturally, just like you showed us, connecting the blinker to the GPIO pin, would you do the same thing to connect the blinker to the GPIO pin to, say, a checkbox in the GUI?
Absolutely, yeah. No, I mean, that's, yeah, because and that was sort of the point of this, the power of the arrow, right? You can hook things up when they're compatible, and if they're not, you know, and by default, things tend to be pretty compatible. Yeah,
I figured. Very cool.
Now it is always related. Then writes to a file to memory. Yeah, sorry.
Sorry, I couldn't make that out. That was mostly interference. Can you say again?
I tried. Do you hear me?
It's still very bad.
Can you try and type your question? I'll just read it out, or I'll answer it then, or.
Yeah, Nicola is gonna type it. Have we got any more question meanwhile? We'll wait for him to type.
What's the status of the project?
Well, it's, I've been using it more and more. Status. I'm hoping to write a compiler, a native compiler for it. I use parts of it in my products. I'm not doing much with those. I'm currently in the process of writing a dissertation at HPI, but I'm also gainfully employed currently at the City Mapper, as I said in the bio. But this has been, a lot of this has been sort of very slow burn for a long time, partly because I think we're at a stage where innovation is really, really difficult, because the paths are so trodden that it takes a lot of unlearning, which is hugely difficult to get somewhere. And so very often I have to just sleep on it for a year, to not, in order not to go down the obvious path. I need to zag a lot where I want to zig. So, but recently things have really just come together, and like I think I was like half a year ago or so, where I kind of hit the tipping point for myself, at least, where I was starting to implement things, for example, in Objective-C, and I was like, I really didn't want to do that anymore, because it would have been so much nicer in Objective-S. But of course, in terms of implementation, I'm not a professional language designer. I'm not a professional language implementer. So it's very in many senses, it's very experimental. I would hope people try it out, give it a shake, and try it out with real stuff as much as they can. But it's, yeah. So I don't know if that actually.
Well, it sounds like you've got people using it. You mentioned there's people trying different things out. So there is a community, and presumably you can make pull requests or something, or contribute in some manner. Is that the sense?
Well, you can absolutely make pull requests. The community is tiny. I haven't really organized it. I also really haven't marketed it much to the people. To me, long time I really didn't see much of an opportunity, because people are very, very set in their ways. Certainly in the pardon, and sort of sorry, and of course. Apple recently, half a decade ago now, put the Swift bomb on us, which kind of went the complete wrong direction in everything. Yeah. But the interesting thing is that people are now starting to notice that it just doesn't really work the way it's supposed to. Partly because the tooling is just, they can't make it work. The compile times are ridiculous. I've seen, examples of, double-digit lines per second compile times for a, 10,000 line project. Swift UI previews are a joke. People have to drastically restructure their projects to make it work and compile at all. Like they have hundreds of little mini projects. Because otherwise everything just falls apart. And so I'm starting to see, it's sort of at the same time that I'm starting to see my stuff working. And my plan is to write a very simple, very Oberon Pascal inspired native compiler that is going to be very, very fast compile. And in addition to the interpreter that, of course, is immediate, as you could see. This is not rocket science, except for, companies that don't understand how to make interactive systems at all. And so I'm starting to, to think that maybe there might be a small niche for a usable interactive tool. iOS and macOS programming, because I mean that is a reasonably large market. Of course, I've also had some requests. I talked to some guys at ASOC, and there's some interest from small talkers who want to do, for example, iOS programming. I'm not sure if it's really interesting. Could be. And of course,
it's really cool. It's pretty awesome. That was going to be my question. It's just like, is there still life in Objective-C if you're based on Objective-C? Like, I've not really followed what Apple was doing with that. Like, it did seem Swift was like a nightmare, and I didn't delve into that. I just sort of said, "Whoa," but
yeah, I mean that's I mean it's so. Yeah, so I mean certainly the community is very much de-emphasizing Objective-C. If you catch those programmers today, they a lot of them simply don't know it. But of course, it's not going away, right? And because so much of the system is written in Objective-C. I'm not concerned about it, my plumbing going away. Also, I started my doing slightly interesting programming things by writing an Objective-C preprocessor at runtime. Objective-C is a very, very, very simple thing, and the runtime is very simple. And there's a bunch of alternative runtimes. There is GNU Step. So I'm just not concerned about my underpinnings going away, because I can always replace them with lots of different stuff. And Objective-C not being ideal as an application programming platform. I mean, nowadays, I mean, certainly Cocoa was Next Step was a revelation when it arrived, and certainly and it's been also very much an inspiration. I mean, the original Brad Cox book talked very much about architecture and how to connect things and trade-offs, and I mean, I can highly recommend that book still today, because it's so different from what people do with it. Because I mean, Apple basically has turned Objective-C into a bad Java, right? And it is a bad Java. I mean, if you want Java, it's not a very good Java, but it's a very good Objective-C. It's a very good software IC implementation language, which has sort of this scripting components pattern, right? Which is you have these components like Unix filters or like Objective-C objects, which you can implement in C or in some other languages, and then you have a layer to connect them that is more dynamic. And this is one of the things I have to admit I don't really like about Smalltalk that much, is although in some sense that is there, the sort of the VM is that that level, is that it's too uniform. And I think most of our stuff isn't that uniform. We have this thing about sort of more coarse-grained objects, and then we get more structure into the system. Whereas when everything is an object, it's a bit more soupy. Although that's like the one side of the equation. Of course, on the other side, you want everything to be the same so you can plug things together. So there's a trade-off. And on the meta level, this is kind of one of the things that Objective-S tries to do, is on the meta, on the language implementation / or meta layer, it tries to apply object-oriented principles to the same way. Like, there are these different things, and it's useful for them to be different. Everything is not an object. Some things are filters, some things are schemes, some things are normal objects. But at the same time, on an implementation level, just like I have a hierarchy of objects at my in my class library, I can also have a hierarchy of components in my meta system, and they can be related. And so in many ways, I can treat them the same. And then I have the uniformity when I want it, and I have the differentiation when I want that. And oh yeah, I forgot to mention, I can of course just put a scheme handler on any particular object. So my browser, I can browse an object the same way I browse the file system, because I just wrap it in a scheme.
But are your schemes and filters, aren't they kind of objects anyway? I mean, you didn't really delve into that. I haven't read up yet, but yeah.
Absolutely. I mean, they're implemented as objects.
Yeah.
Right. And I mean, it turns out that you can actually and do all of this is and you get many of the benefits, for example, at both at, of course, at the BBC, but also at Wunderlist. Of course, I didn't use Objective-S because, you know, I'm not going to propose it, and they wouldn't have accepted it anyway. So you get a lot of the, I mean, you get a lot of the benefits by just using these patterns, these as just normal objects.
So when you said the object graph in Smalltalk is kind of, I think you said soupy. I kind of what you mean. I mean, everything's an object. It's all just pointers from objects to objects and objects. There was something cool I saw, like when I first saw Next Step, like the Unix file system, it's all just files and directories, this giant hierarchical tree, which can get confusing because everything that has multiple files is a directory. But when it was presented by, I can't remember what they called the Finder in Next Step, but they had these special directories. They weren't really special, called packages. And you know, from the soupy point of view, it's all just directories, but it gave some more chunkiness to it. So you could say, this isn't just a directory you go into. It's like a directory that's harder to open. You're dealing with it at a higher level than the fine-grained directories beneath it. So, I mean, so I'm getting a similar sort of feel from your architectural system, that even if it is objects all the way down, you're dealing with, I mean, you know, dare I call them like architectural facades, so you don't have to dive too far into the internals. Is that close?
Fantastic. And actually, I use bundles also in the implementation, and there's, you know, like the last, you know, the first 10 years, I actually never had any GUI stuff, and now that I do, I'm starting to reproduce also sort of, you know, facilities from the image using these types of bundles. And exactly, it's like we can treat these, I mean, that's what polymorphism is, right? It's like we don't have to, we can treat things the same at some level and different in other levels at the same time. They can be the same thing because they have interfaces. And it's interesting that, you know, we kind of didn't do that for our meta system. And of course, Plan 9 didn't, you know, Unix left, and then there Plan 9 is, you know, very good idea, right? Hierarchical namespaces are I think are a very, very good idea. But then, you know, you need to talk with the POSIX interface with everything. And it's like you want to kill yourself, right? But it, you know, so yeah, you know, spot on. Yeah.
Okay.
Marcel, your comment about being able to do a lot of this with just the patterns, etc., kind of leads into my question, which is, if you had to choose which of these patterns to backport, if you like, or to implement in the mainstream Smalltalk dialects, which would be the key ones that you would suggest adopting?
So I would. So we actually at HPI, one of the master students implemented polymorphic identifiers in Smalltalk, which was not a lot in Squeak. And you can have a lot of the benefits without them by just using strings, although then it gets a little less nice. And so that's I think that's one of the biggest ones. And actually, there used to be a tiny implementation of the polymorphic write streams in the like way back. When Dan was doing, he wanted a PostScript version of the Back to the Future paper, I think, which was, you know, done in bookmorphs, I think. And so I did a PostScript writer for him, and that's been in the Squeak image since forever, and that was based on my other stuff. So that's been in there. And again, that actually also works in most programming languages. I've done a C# version, I've done a Java version of that. It's not quite as nice because, you know, it's not dynamic enough. So those are the biggies, I think.
It seems to me that pipe syntax would be very powerful as well.
Which?
The piping syntax, the, you know, connectors involving pipes and the streaming from.
Well,
from-
yes, yes. So I mean, the piping syntax is just the connecting syntax, right?
Yeah.
That yeah, you probably could. At some point, it's going to be diminishing returns, but I mean, it'd be interesting certainly to find out if you can do it.
Mhm.
And again, you can get a lot of the. I mean, Smalltalk is flexible enough that you tend to be able to hack it. I mean, one of my favorite articles when I discovered was like was it Will Lalonde or something, when they did the Prolog style backtracking without any VM support, and I thought that was just the coolest thing ever. And of course, but it also showed me like nobody's going to use it. Nobody actually used this in production. And that's something that I've noticed also with Objective-C, which has, not quite, but also fairly sophisticated, fairly good metaprogramming facilities, is that, yeah, you can do all this stuff, but oftentimes you don't want to, because you also don't want, 99% of your program in the does not understand handler. And so at some point, it seems to me that what you want is you want to have a language, and that was sort of, I mean, that input was, and combining that with some of the other stuff led me to say, well, actually, I think I do want a separate language where I don't have to hack all this stuff anymore, right? And I'd like to make it flexible enough so that more of the same can be plugged in, a class meta object protocol style. I mean, I called my company Meta Object in reference to that book. But just instead of whereas class is sort of takes oop and kind of says, well, we're going to make that a little bit more flexible at the edges, so you can you make that if you sort of view that as a sort of a space, there's a point which is a single language, and class like expands that a little bit around. And the idea with Objective-S is just to say, well, we actually going to put some pretty far away points in this space, and then you're allowed a much greater leeway of where you want to place your stuff. So you can, there's idea. I mean, the conceptually it has all the support for the filters, procedures, storage, and a couple of other things that you need to go with them. And then you can start playing with them and putting them together. And when you look at bigger systems, they tend to re-implement something you have in the smaller system. Like there's messaging systems, right? But they don't use the messaging facilities that you have. They have this separate, and then you have like Kafka and whatever you call them. They're streaming, but they don't do. Everything is always implemented from scratch separately and not integrated into the language. And it seems kind of silly. Okay, I'm not going to read the question from Nicola, because we promised, I think. Yes, but in Linux you can access two-way. Yes. Oh, okay. Yes. There is also a way to the question. I mean, I think everybody saw it, but in Linux you can access the GPIO in two ways: file and direct memory access. Yes. And the file access is kind of nice. It's kind of slow, and the problem is it then looks kind of like a stream, but it isn't a stream. So apart from the performance considerations, which are also relevant, yeah, I've also played around with the doing it via the file system, and it doesn't quite fit. It's a little bit too clunky, and that's probably not a very deep answer, but that's what I have. And it's it doesn't quite fit, and it's just like Plan 9 had everything as a file, and just some things aren't really files. I'm sorry, you can make them into files, but they're not.
Sort of like the way the /proc file pseudo file system in Linux. If you want to get your PID, you can just open /proc/self, whatever. But it's so much more efficient just to call get bid.
It's more efficient, and also, I mean, I love all the fused file systems, you know, and then it's also, of course, an inspiration, and of course, I also, you know, did that but we also did that with a company I worked for. We kind of mapped that onto there, and it just. It doesn't really fit. It has lots of really nice properties, you know, particularly
It makes it more accessible for someone who's casually playing with it. Everyone knows how to read and write files, so it makes it more casually accessible to playing around with.
And browsable, right? And you can immediately get it. And again, my idea was with this was, why not both? You know, why not have the accessibility, but still have it be nicely, have it be a nice API at the same time? And it turns out, I think you can do that. You can actually have both at the same time. And it kind of reminds me, because we have all these dichotomies. We have lots of these dichotomies in programming. And it reminds me of the, you know, in the like early 90s, when we had this, you know, set in stone dichotomy between server operating systems and, you know, client operating systems. And the client operating systems were colorful and clicky and nice, but crashed all the time. And server operating systems were horrible and unfriendly, but were stable. And it was a completely false dichotomy, but everybody accepted it, right? And we accept just, I think, way too much of this sort of bullshit, pardon my French, as God-given. And instead of asking, wait a second, why can't I have both? You know, like, is there really a good reason why I can't have both? And it turns out, I think, in many of these cases, yeah, we can have both. And then and sort of, you know, the interfaces are sort of to show that, yeah, and actually, once you have it at this more abstract level, you know, yeah, you can do fuse in you know, it's usually 2 lines of code. And yeah, you want an HTTP server? You know, there are some people who say everything needs to be HTTP. Yeah, sure. Why not? You know, have HTTP. Go ahead. I don't care. But I'm not going to, you know, be messing with Ruby and string handling all the time. I'm going to write my little in process schemes. And if somebody wants, you know, if we want to connect them in process, that works. And if somebody wants to connect them out of process, that works too, because it's just, at that point, it's just a generic interface that I can just slap onto anything I want. So I'm lazy.
How do you debug this stuff?
Okay, yeah, no. Though, so debugging is something that I think actually will benefit greatly from, or could. No, I think it will benefit greatly from having these better abstractions. Right now, of course, debugging a pipe using a procedural debugger is not nice. You need actual support. But since you have now have these structures, you know, you can like have like visual representations of the data flows. And because it's not, so I mean, actually debuggability is also one of the reasons that you want the language support for the connectors, right? Because if you make a connection and oftentimes you can do it almost as cleanly, right? I mean, you can always abstract it in a way enough that you can do the abstract, you know, that you can do the connection in a single method call, typically. It'll be a different method call every time, so you don't have the nice polymorphism and other problems. But one of the biggest problems is that it's a method call. And so we go back to, you know, what Andrew Black said is, and actually also what the functional boy says. So they're actually, they're correct about this, surprisingly, that, you know, object orientation, when done right, is a lot about hidden state, because when you do the connection, it has to be hidden, right? Because the method returned. And then some hidden thing changed and is now connected. but but because that's hopefully going to be in the framework, right? Because you don't want to rewrite it all the time. And the client code is just this procedural connection code. That means now the connection is somewhere deep inside the framework, and good luck debugging, right? I mean, I had an article that I blog posted published a long time about the siren call of KVO, key value observation and bindings in Cocoa, which does some of the the bindings, this very data flow constraints for GUIs, and and they've pretty much fallen out of use. And I've also removed them from just about every project I've been at, because they tend to be completely undebuggable, right? Because it's all hidden. It's just, magic messages flying around that you have no control over and you can't see. There's no introspection. Whereas if you have a right arrow B, you have a place to put the debugger at, right? At that arrow. That's where the stuff flows. Now I haven't implemented that, but it makes it possible to actually, debug these kinds of things. And
you've got something to put a break. You've got something to put a breakpoint on.
Right.
That
and probably an observer or something, right?
Yeah.
You hook something into there and say, hey, right? Whereas when you set it up with a procedure, it's in, it's gone, and good luck. And of course, the functional boys, I mean, again, they as much as we hate to admit it, that sometimes they have a point, because, you set things up procedurally in object-oriented programming, and then the connection is implemented procedurally, right? And we say, but you need these objects. And they're saying, well, but it's all procedures, right? Why not just write functions? And, it's short-sighted in some ways, but they do have a little bit of a point, right? And to me, in some ways, object orientation is kind of nowadays, and yes, hubris is knocking at my door, but it seems to be the better old thing, right? It's the almost architecture thing, because we can, once again, we can build the architectures, but we can't express them.
Right. Okay. Thank you. That's very helpful.
Thank you. Okay, it's very late.
Yeah, everyone's gone quiet.
Everyone's gone quiet, and I think most people, and a lot of people, have left. I think unless there's more questions, maybe I should call it a night and let you all lovely people go and get some sleep. And thank you very much for your attention.
Question that is.
Oh.
Question
Thanks, Marcel.
that is just quick or short, or long as you want it to be. I was curious, since you mentioned functional programming, if you took any inspiration from similar frameworks in the functional programming land.
Inspiration-ish, sort of. I mean, they kind of, so React in terms of the UI stuff. Oh, well, actually, yeah. So there's 2 bits that are interesting. Well, 3 bits. Lenses for the store stuff. And there might, I don't think, I mean, when you look at it more closely, it always seems to be that they just need to do a lot more stuff to do basic things that we take for granted. But I think the compositionality is kind of interesting, and I think it could be a good theoretical underpinnings for what I'm doing with that. But I'm not entirely sure. So, it'd be probably great if somebody else did, some analysis, and maybe just, put the whole thing on a more mathematical foundation. That'd be really neat. So the other 2 were more sort of anti-patterns, I think. So I was really fascinated for a long time with this whole FRP movement, and I couldn't get my head, I couldn't wrap my head around it, because it seemed to me always like it was either just constraints, what they talked about, right? They when they describe what it does is, yeah, that's data flow constraints. What are you talking about? And then, no, it's functional. It's like totally functional. It's like, no, it's not. It's like there's 2 variables and you connect them with data flows, or it's data flow, right? And data flow is cool, right? I mean, I'm a great fan of data flow, but they kind of implement it in the most horrendously, backwards way, because they go via functions which are not very data flow compatible, and also not very constraint compatible. And it turns out that, in order to do this, they have to then, put everything, sort of make everything high order mechanisms. So all your, and some of my colleagues at, for example, Wunderlist did this, and I think there's some at CityMapper as well, but I'm not sure. And so you always have to put your actual, the code that your domain code inside of a block of an anonymous function inside sort of the thing that they're generating, and it's just a mess. But people are really excited about it, and I think what they're excited about is the data flow part. They just don't know it. And then I just did most of the examples, and I redid them, and it turns out that with the data flow parts of the polymorphic write streams, you can do all this without any of the higher order stuff. It's just base order. It's just like Unix pipes, right? Because you don't need separate collect or filter and alt map and whatever in your processing, because the stream will just write the thing, and it's incremental, and it can do all this at the base abstraction level. You don't need to go higher. So that's that, and of course, something that's gotten a lot of traction recently is the React stuff, and then everybody and their dog copied it. Swift UI is the same thing. And again, they have a point, right? Because constructing GUIs from procedurally is a pain. The metaphor I tend to use for that is, if you had to construct sentences by describing, by procedurally describing the words that you're putting together, right? So instead of saying the boy hit the ball, you're going to have to write, take the noun boy, add the definite article the in front of it, behind that add the verb hit, and so on and so forth. And that's basically when we construct GUIs in most object-oriented languages using the language facilities, is what we have to do, and it's awful. And they have, once again, they have a point. This is completely stupid. And so what they said, and this is really interesting, that their idea is that what they're doing is finding some deeper meaning that the React has as their motto, like the GUI is a pure function of the model, right? Which is a lie. It's not. And I actually talked to the guy, and he said, well, you don't have to, you mustn't take this so seriously, and we're not so strictly. And it's like, well, pure is a very strict word, right? If it's just some kind of random mapping, then any GUI that's not a mapping of your model, it's probably not a GUI, right? It's like, what is it then if it's not mapping your model? So if you remove that, then what is it, right? And it turns out, I think what it is it's just the convenience, right? Because it turns out that in our programming language, what we can actually write down directly is procedures. We can call them methods or functions or procedures, but they're basically procedures. That's what we can write. We can't even write objects, right? We can only write classes that group procedures together as a second order mechanism. But primarily, I think all of us are basically procedure writers. That's
you mean as an imperative.
And mostly imperative, but it doesn't really matter that much if they're functional for this particular thing I'm saying. But I mean, not that it doesn't make a difference, but for this, it's not. So this is what we can write down directly. Well, writing things down directly.
I'd mentioned that self has a literal syntax for objects, so it's trivial to have completely new objects in the middle of your code.
Yeah, I assumed it did. I'm not fully familiar with it, so yeah. And again, most of this stuff isn't, most of this is actually not rocket science, and most of it has been done before. I'm just sort of collecting and curating, and with a couple of innovations. But anyway. Wait a second, no, that's the right mute level. Yeah, and so and of course the really good GUI builders are sort of DSLs, right? And sometimes they're visual DSLs like Interface Builder, because of that. And so, yeah, so that's kind of, and async await is just sort of the same deal, right? Is that we're trying to map things that are not procedural to procedures, to call and return, and it's getting more ridiculous, sort of by the year, because I mean, async await is like, I call it the the epicycles of call and return programming, because it's just, you pretend that these things are procedures and they're not, and it takes about, I mean, my colleagues at HPI, they started playing with the JavaScript async await stuff, and they ran into a problem, and they were just doing basic stuff. They were not trying to push it, with where the procedural representation was not indicative of what was actually happening, and that caused a bug, and they hit that within like half a day. Right? Because I mean, rewrites everything to be something completely different, and it's just, okay, that's not a good idea. So these are some of the, these are inspirations, certainly, but a lot of them are sort of anti-inspirations in terms of where I got the title of that old talk, which was like the tyranny of call and return, because we're trying to more and more. We have systems that do not fit the call and return mold. And we are trying to fit them into a call and return mold, and it's getting more ridiculous, by the year, because it just doesn't fit. I don't know if that was what you were going for.
Well, it stopped me stopping the recording because it was like really interesting. So we're still recording because there's all these gems that are coming up. So thank you.
So Marcel, hi.
Hello, Marcus.
I didn't get that with that React thing. You were just getting to the punchline, and then came the question with self, and or at least I didn't get it. So what is the main metaphor, the trick of this React thingy? I would be really curious to understand.
Okay,
so that from your architectural point of view.
From an architectural point of view, I mean, what they get two things out of it, as far as I can tell. One is being able to write your UI in sort of a how do you say? I mean, like the Lisp people say, like the homomorphic. No, I'm not sure. No, that's something else. But
homoiconic.
Yeah, homoiconic, kind of, right? It's like you can sort of directly write down something that reflects the structure of the thing that you're building, right? And that is really valuable. And I think that is where much of the excitement comes from, is like being able to do that. But the price they have to pay is that actually doesn't work, right? Because it's not. And I have a blog post where put this like in parallel, and it's like, that's why they keep having to change it around, because it's not true. It is a nice fiction. If it were true, it would be awesome, but it's not true. And so they they keep on thinking that the reason it's not working is because they're not purely functional enough. But the more purely functional they make it, the worse it gets. Because GUIs are about state. They have lots of state. They just do. That's the way they work. And a GUI is a separate thing. It is a thing that maps the data of your model. It is not, and so that's the second thing that they did, is because because that way you can write it down as a procedure. You write down that you have one procedure that not just fills the GUI with data that as a separate thing, but actually builds the GUI as and the GUI then becomes it's like an ephemeral like construct, right? It's not a thing. It's not solid. It can change on every key press. I think Gilad had a it's like every time you change the light bulb in one of your in one of the apartments of your skyscraper, you blow up the whole skyscraper and rebuild it from scratch. And actually, it turns out you do that even if you just turn the light switch on and off. right? And that seems insane for sort of, practical reasons, but and they have to do a lot of work, right, with all the diffing logic and stuff that doesn't actually happen. One, because it's it's crazily inefficient. Okay, machines are fast, but still, and also conceptually it doesn't work, right? Because for the user, the GUI is supposed to be solid. It is supposed to be the solid thing, except for things like games. And it turns out that, a lot of where this comes from is games and, things like Facebook, which are sort of where you're sort of passively getting information, and the web. And it's now being applied to things that are supposed to be more traditionally GUI, where the GUI is supposed to be the most solid thing. And again, that doesn't really make any sense. And I in that blog post, I just outlined all the hoops they when React has this page where they describe their principles, right? And then they describe all the things that they do, and 90% of that is like hoops we jump through to somehow get state back again. Okay. And then back next to it, I just write, well, or you just put the state in the GUI, and then you keep it around.
Sorry for not having my camera on. Privacy settings, I need to switch them on, and yeah, too much of a hassle right now. So anyway, thanks for that. And I'm kind of, currently happy to program Smalltalk commercially, but this will not last forever. So I guess I'm not the only one who has the problem to, what should I program? And that would be nice to have some GUI also as well. And I guess it will be web-based. So then there's Marcel, who knows how to do kind of very aesthetic and easy understandable architectural things. So what would Marcel suggest? Which direction, if Smalltalk, if Objective-S is not kind of taking off commercially in the next year for selling it to some bigger companies or so to use it as a backend or whatever. So long question short, is Flutter a thing to look at, or what would you suggest to go, which direction? What do you think would be kind of, from an architectural point of view, a nice, the nicest thing? Maybe you have some ideas on that. I would be curious to know.
Yeah, so I truly don't know. I mean, my Objective-S is personal self-defense, right? Because everything I see is just, oh my God.
Exactly.
They're all moving in the wrong direction, right? And like, yeah. I really don't know. I really don't know. So one thing that I think, looked kind of nice was Svelte. I mean, it's like very minimal, and it looks kind of elegant. In the web field, Svelte. SVELTE.
Okay.
They do sort of constraints, and are as a fast and simple alternative to React. Of course, it doesn't have the ecosystem, but then again, maybe you don't want all that ecosystem.
I guess ironically not popular, and so like no one likes the good stuff. It's
okay. Yeah. Mm-hmm.
Well, we might know about this.
Yeah,
it's a fashion industry. Things get wildly popular, and then there are backlashes.
Yeah.
I mean, then there's also like, I just kind of bringing things together here randomly. So sorry for kind of diverging a bit from maybe the main point of this talk, but maybe you can connect it because it's an architecture. Have you looked into this croquet thing, and would that somehow maybe work? Like kind of connecting that to lots of different things could be interesting. I don't know. Or you guys know what I'm talking about, I guess.
Which you mean the
new one, the croquet.io thing from all these guys, Vanessa Freudenberg and Yoshi and David Smith and so on, where they do this kind of synchronous real-time collaboration framework where you don't have any servers. They have kind of this JavaScript language backend, and just kind of I don't know, maybe it's no fit at all, but there might be something. I'm kind of looking into something nicer to program against that, and which would might possibly glue that also to other interesting things, especially in the mobile area. So like iOS kind of would be AR, this direction.
Not
this is
familiar.
a total
I
new
know
space.
the old
and
croquet stuff. I don't know this at all.
Okay.
Yeah, croquet.io. It's worth checking out.
Yep.
Are you working on it, Craig? Or
Yeah, quite heavily. Yeah.
So what do you think, Craig? Is there some space here? Some, at least maybe you can use some patterns here, or is there even a direct application of what Marcel is doing towards this croquet.io? Or?
I think anything that has to do with multi-user behavior and which has some interface to JavaScript should definitely check out Croquet. Yeah, it's useful for a lot of different things.
I mean,
my main project with it now is sorry.
Yeah, it's another architectural abstraction in a way, what Croquet is doing, and Marcel is good in describing architectural abstractions. So why not kind of interfacing against that in a way, kind of. I don't know how, but
yeah, it's a great way of doing what would normally be server-side things at the edges instead. Yeah.
Anyway, you can look at that. Let's have a chat or a real time, real meet up again, Marcel. Maybe I come to Zurich or I come to
maybe this is a good point that I'll stop the recording and just, Marcel, thank you for talking us through all of this stuff, and actually for all the participants for some great questions. I learned a hell of a lot. I'm not saying that we'll go, and I'll just press stop on the record, and I'll press the right button, because last month, you'll recall, I said bye to everyone. I closed the whole damn thing.